Okay, on page 217, it talks about the definition of a radian measure, which you talked about over the last couple of days in class. And then there's these conversions that we talked about the other day. You have to have these conversions memorized. So, if I go down here and I do number 1, I have 30 degrees and I want to convert to radians, so I'm going to multiply by pi over 180, and the 180 has to go on bottom so these degrees cancel out. So you have 30 pi over 180, and when this reduces down, you should get pi over 6. So if we try number 2, you're going to have 45 degrees times pi over 180. The degrees are going to cancel out, and then when you reduce 45 over 180, you're going to end up getting pi over 4. So pause the video and then come back and check number 3 and 4. So on number 3 you should have gotten 2 pi over 3, and on number 4 you should have gotten negative pi over 3. Okay, so now we're going to convert the other way. I'm going to cover my answers down here so you can't see. So I have 3 pi over 2, so I need to multiply this by, pi over 100, nope. That is backwards. I need to multiply by 180 degrees over pi. Like the pi's to cancel out. When you take 180 and divide it by 2, you get 90. 90 times your 3, 270 degrees. Same thing here. I'm going to multiply by 180, divide by pi. My pi's cancel out. 180 divided by 6 is 30. 30 times 5 is 150 degrees. Pause the video and come back and check the next two. So you should have gotten 315 degrees and negative 330 degrees. Make sure you don't drop your negative on number 8. Okay, on the next page, just gonna grab a little cards and cover my answers. On the, not the next page, or the next set of problems. Because I have dealt with radians for a long time, I know that this lies right there. But the easiest way for you to do it right now is take 3 pi over 4 and convert it to degrees. So when you do that, you get 135 degrees. And you should know that 135 degrees falls to the second quadrant, making your answer quadrant 2. Convert the next couple and then come back and check your answers. So number 10 is in quadrant 1. Number 11 you should have gotten quadrant 3. And number 12 should be quadrant 4. Okay, the last part is a little bit tricky because it wants to convert into revolutions. One full revolution is one full rotation around the circle, so that's one revolution. And we've talked about how the whole circle has 360 degrees, or 2 pi radians. So what you're doing is you want to know what part of the whole this is. Well, this is in radians, so to find the part of the whole, you're going to take 5 pi over 4, that's the part that you have, out of your 2 pi. So you can get 5 pi over 4 times 1 over 2 pi. Your pi's cancel out, so you have 5/8 of a circle, or 5/8 revolutions. Number 14, same idea. It's in radians, so 5 pi over 3 over 2 pi, which is going to get you 5 pi over 3 times 1 over 2 pi. The pi's cancel out, and you get 5/6 of a circle, or 5/6 revolutions. I'm going to skip number 15 for a second and come back to it. 16 says you 142 degrees out of your entire 360 degrees. It's not a pretty number, so I'm going to use my calculator to reduce. I'm just going to type 142 over my 360. So I've gone 71 over 180th revolutions. In the next video, we're going to talk a lot more about number 15, but what you need to know right now so I can get you to do the problem is that this is in degrees, minutes, and seconds. And so to convert this back, you're going to take your 345 degrees and add it to 11 over 60, because there's 60 minutes an hour, plus 12 over 3,600, because there's 3,600 seconds in an hour. And so now what I'm going to do is I'm just going to type in my calculator. 345 plus 11 over 60 plus 12 over 3,600. And you want it to approximate the answer for you. So this is about 345.187 degrees. But I don't want to go to degrees, I want to go to revolutions. So you should divide this by 360. So I'm just going to take my answer and divide it by 360. Control Enter. So I've gone 0.959 revolutions, almost the entire circle, which makes sense because you're at 345-ish degrees and there's 360 degrees in a circle. Go back to Edmodo and there'll be another video that posts to help you out so you can fill out pages 221 through 222, which are due tomorrow.